This lesson is for FST 5.1 on SohCahToa. Before we get started, I just want to reiterate to students that rounding is going to be a big deal in this chapter. So with chapter 5, make sure you pay attention to what each question tells you to round to. Even if you show correct work, if you round incorrectly, you will lose points. So please pay attention to that. I'll try to make mention of it in all of our examples as well. Also, students will need a scientific calculator during this chapter. If they don't have a working calculator right now, they will need to obtain one. Scientific calculators are fairly cheap. Students need to make sure they have a working scientific calculator with them at all times in Chapter 5. Baby calculators are always provided in class, but those do not have sine, cosine, and tangent buttons, and so students without a scientific calculator will be out of luck. Please make sure you bring an appropriate calculator with you to class daily. SohCahToa is an acronym that students have probably learned in the past. We're going to review it today in this lesson as an acronym to help them remember trig ratios for right triangles. During this chapter, we will be working with right triangles as well as non-right triangles. So it's super important that students remember that right triangles go with SohCahToa. If it's a right triangle, you should probably use SohCahToa in some fashion. The acronym itself is to help students remember what ratios go with sine, cosine, and tangent. The S goes for sine, C for cosine, T for tangent. And so when you're working with that acronym, the rest of the acronym helps you remember what ratio goes with which trig function. The O and the H go with sine, A and H go with cosine, O and A go with tan. So when you're labeling a triangle, you want to look for which pair of pieces of the triangle go with each one. Keep in mind that when you set up SohCahToa, you'll only set up either sine, cosine, or tangent on each problem. After you write sine, cosine, or tangent, there will be an angle measure listed next. Usually it'll be a number. Sometimes the angle measure is unknown, and so it'll be listed as a letter or as the symbol theta. Keep in mind that the acronym SohCahToa doesn't include the piece about having angles, so that's just something that students will have to remember to do. When you're setting up SohCahToa, H stands for hypotenuse, and most students I think are pretty comfortable with the idea that the hypotenuse is the longest side. When in doubt, especially if there's no labels given and you don't know which side is the longest, the 90-degree arrow here points to the hypotenuse side. So it's important that students just abbreviate HYP and label where the hypotenuse is. The other two pieces of the triangle, of a right triangle, are called the legs. And to determine which one is opposite and which one is adjacent, it's important to figure out which angle you're referring to. So let's use theta, and let's mark this angle down here. So if this is the angle that we want to focus on, then we need to be able to label the legs as either being opposite or adjacent in relation to that angle. So this side down here, the horizontal side, is right next to this angle, and that's another idea of being adjacent. Adjacent means next to. So this leg would be the adjacent leg. This vertical leg over here is going to be the opposite leg because it's across from where the angle is. Keep in mind that if you change which angle you're working with, so let's say we switch now and talk about this angle up here, now this side is no longer opposite of this angle. This side now becomes the adjacent angle, or excuse me, the adjacent side to the angle. And then this side on the bottom here, which used to be adjacent to angle theta, is now across from or opposite angle x. So know that where the opposite and the adjacent labels go is dependent on which angle you're working with. So let's go ahead and put it into practice. One more quick thing here is that when you're labeling a triangle, keep in mind that the capital letters are used to refer to each vertex or each angle itself, and then the lowercase letters are used to talk about the side across from that angle. So lowercase a is going to be the same as side BC. Back when you were in geometry class, side BC would be labeled as B with C next to each other with the segment bar above it. So side BC is the same as side little a. Those were referencing the same length. And little a has to be side BC because it's across from angle A. So then we would know then that side B which we would label with a lowercase b, is across from angle B. So then same thing with side C. So just pay attention to how your triangle is labeled. If it's an uppercase letter and you want to talk about a side, you'd want to put two of those together. If you're trying to label with lowercase letters, you would go across from the angle to label it. Let's go ahead and put SohCahToa into practice. On this first triangle, there is a 90-degree indicator here, even if it doesn't look like it's 90 because of the inclusion of this box. You know then that this is a 90-degree angle. Know that when I draw these triangles, I do not measure them accurately. I literally just sketch them out. Go by what the label says, not by how it looks. So this angle here is across from or opposite to the side that we're trying to find. The hypotenuse side is across from the 90. The 90-degree angle points to it, so that is the hypotenuse side. Know that this side here with the 510 is also adjacent to the 50, but the hypotenuse label will take priority over that. So if you're not sure if it's adjacent or hypotenuse, if it is a hypotenuse, that should be the label that you give it. Since we have only two pieces, opposite and hypotenuse, O and H, I go back to my SohCahToa, and that would be a sine problem, because sine involves opposite and hypotenuse. So I'm going to set up sine here. And remember to always do sine of the angle. So I'm going to say sine of 50. And then we do opposite over hypotenuse, O over H. So students would get a point for labeling with opposite and hypotenuse on their actual triangle. They'd also get a point for setting up the sine problem as we did here in red. An additional point would happen if students solve correctly by multiplying by whatever's on the bottom on both sides. It's important that students put the number that they're multiplying by in front of the sign, because if you put it after, it's unclear if you should multiply the numbers together and then evaluate it for sine, or if you're doing sine of 50 and then multiplying by 150. So just be careful there, you don't want to multiply in the wrong order. If you put the number in front, now it's clear that we're going to do 510 times sine 50. When you type that in on your calculator, you want to make sure that you're in degree mode on your calculator. If students need help with that, they need to ask for help prior to a quiz or a test. When you type that in, you get 390.68 with some other decimals there. So let's talk about how you would round that properly. If we rounded that to the whole number, we would say 391 for the question mark. We would use a squiggly equal sign here to indicate approximately equal to. Know that if it asked you to round to the 10th, you would have now lost a point, because rounding to the 10th, it should have been 390.7. So just make sure that you know how to round properly and pay attention to whatever it says. This question doesn't say, so we were just simulating what could happen in that situation. Let's go ahead and try the next one. Again, we're going to label what we have in relation to the angle that's marked. 85 is adjacent to that angle, and the question mark side now is the hypotenuse side. So the part of SohCahToa that addresses A with H is cosine. So I'm going to set up a cosine problem. Cosine of the angle is equal to A over H. So I'm going to say 85 over question mark. Now I want to solve for question mark here, but question mark is in the denominator, and you can't solve for something when it's in the denominator. Some kids here will say that they can divide by 85 to get rid of the 85, which is true, but it doesn't move the denominator out of that spot or out of that position like we need. So dividing by 85 here isn't wrong, it's just a step that's unnecessary. What'll be faster and easier for you is if you multiply by question mark on both sides. Notice that that is the identical same step to what we had done previously. On the sine problem that we just finished, whatever was on the bottom gets multiplied. Same thing here, the question mark's on the bottom, so we're going to multiply by that. What happens on this side is that the question marks cancel, which doesn't really help us right now, but what it did do was it allowed us to move the question mark from being in the denominator to now being a regular number. So now to get question mark alone, we would need to divide by cosine 30. Keep in mind that cosine 30 is a group. They are attached to each other. You wouldn't be able to divide by 30 and then divide by cosine as separate steps. They travel as a group. You can never do just a cosine without a number with it. Now when you type this in, 85 divided by cosine 30, if we rounded to the whole number there, we would get about 98 there, I believe. And again, if they asked you to round to the 10th, you would have just gotten it wrong because you would have needed to include an extra decimal there. So I want students to try one on their own. You will need a scientific calculator in order to answer this question properly. Go ahead and pause the video and give this one a try on your own. If you went ahead and labeled this, you'd notice that this is opposite of the angle, and this side here is adjacent, so this should be a tan problem. So we would do tan of 16 equals opposite over adjacent for TOA, and then I'm going to multiply on both sides by, that angle should have been a 26. So then to solve for question mark, I would multiply both sides by 16. You type that in. If you round it to the 10th as it asks, you should get about 7.8. So students have now had a chance to see a sine, cosine, and tangent problem. That's the basics of SohCahToa. Now let's get into some word problems. When working with word problems, on occasion you'll hear the problem mention an angle of elevation or an angle of depression. The biggest thing for students to remember these is to know that they come from a horizontal. So if you draw a horizontal line, if you do a line below that, this angle that's formed here is an angle of depression. So is this, but usually the one that we need is the smaller of the two. So there's two angles of depression formed there. If you go from a horizontal and you go up from there, the angle that you just got here is now an angle of elevation. It goes from a horizontal up. This one is also an angle of elevation, but usually the acute one is the one that we're looking for. So keeping that in mind, we're going to look at our first word problem. If a flagpole casts a shadow 24 feet long and the angle of elevation from the ground to the top of the flagpole is 25 degrees, how tall is the flagpole? I will ask students on occasion to draw a picture. Know that your picture doesn't have to be artistically accurate or correct. Those of you who are artistic, go for it, but know that I'm not going to be critiquing your artistry skills. Flagpoles have to be perpendicular to the ground, so there's an implied right triangle in this question, even though it doesn't say it outright. You can go ahead and assume that this will be a right triangle because of the mention of the flagpole. You have the option to draw your triangle to the left or to the right. I'm going to draw it to the right. Know that if you drew it to the left, it would still be perfectly fine. Go ahead and make it a right triangle because we know that it is a flagpole that is perpendicular. And now let's start labeling. The shadow has to be on the ground, so that has to be your 24 down there. The angle of elevation, the only piece of this triangle that is horizontal is down here, so the only angle of elevation we have or could have is down here at 25 degrees. Notice that they do give you a little bit of help here by saying angle of elevation from the ground to the top. Keep in mind that if that phrase weren't there, you'd still be able to figure out that this was the angle just by the inclusion of the phrase angle of elevation. As soon as they say that, look for the horizontal and figure out if you're going up or down from there. Up indicates an elevation angle, down would indicate a depression angle. So now we have everything we need. We're trying to find the height of the flagpole, so I'm going to call that missing side H. Know that you could have called it anything like X or F for flag or T for tall. Based on what we have, I see that we've got this angle and H are opposite of each other. The angle and the 24 are adjacent to each other. Since I've got O and A, that's a tan problem. So I'm going to say tan 25 is equal to H over 24. To solve that, again, just take that bottom number and multiply on both sides. So now I have 24 tan 25, and if I round that to the whole number, I would say about 11. If they said round to the 10th, you would have just lost a point. Rounding to the 10th, you'd get about 11.2. We have one final question to look at, and that comes from your textbook in example 2, page 295. Sonar is something that students need to be generally familiar with, not specifically familiar with, And if you need more information about sonar, I have a couple links here. Both of these links are from a movie called The Hunt for Red October. In the first clip, it just uses information from that movie to help students just hear the different pinging sounds that you hear in the sonar. There's a torpedo that's almost going to hit a submarine, and the submarine maneuvers out of the way, and the torpedo hits a mountain under the water instead of hitting the submarine. As the torpedo is approaching, you can hear the sonar beeping through the water. And then there's a very famous line that Sean Connery delivers in the movie later on. Real short clip here is about using a ping, which is that sonar sound, to verify a distance under the water. And so the phrase is one ping only, and that's a very famous phrase from that movie. So if students want more information, they can check out those clips on YouTube. We did watch those in class, so if students were in class, they've already seen the clips. Information about the movie real quickly, since I've got it here. The Hunt for Red October was the first Jack Ryan movie starring Alec Baldwin as the character Jack Ryan. There have been other films related to that character. Most recently, Chris Pine played Jack Ryan in the summer of 2014 as Jack Ryan, the Shadow Recruit. So there have been other movies like The Hunt for Red October about that same character. So if students are interested, they can go ahead and check those out. In our example, real basic example, we've got sonar from a boat located an object under the water at an angle of depression of 50 degrees. The sonar equipment says the direct distance to the object is 510. That's what the sonar does, is it verifies a distance using sound. And we want to figure out how deep the object is. So I'm going to draw my very crude version of a sailboat, which is sitting on the surface of the water. The boat uses its sonar to locate an object under the water. That object is unknown. I'm just going to make it look kind of like a fish. Keep in mind that when the book talks about the sonar wave, kind of uses these little hooks to indicate that the sonar is headed out in a certain direction. Now from here, we can draw two different triangles. We can do a connection to the right and get a right triangle this way, or we can do a connection down below and get a right triangle that way. Either triangle will work. However, because of the inclusion of this phrase, angle of depression, it would be better for us to use the triangle this way. Our angle of depression is right here. It's going from a horizontal downwards. If you did the triangle over here, I'll show you what that would result in at the end of this example. So our angle of depression is 50. The direct object distance away is 510, so that's going to be this length here. And I'm trying to find how deep the object is from the surface of the water down. So I'm going to call that D for deep. Based on what I have labeled now, related to this angle, I've got the the opposite side, and this side is the hypotenuse side. Opposite and hypotenuse come from sine, so I'm going to set up a sine problem. Sine of the angle is opposite over hypotenuse, and we already did this question at the beginning of the lesson today, so I'm not going to complete it here. Hopefully students can look back at their notes and figure out what that answer would be. Let me just quickly touch on the fact that if you drew your triangle differently, you could still get the same answer. If we drew the triangle this way, 510 would still be our hypotenuse, but now our angle of depression is not in the triangle itself. Back when you learned geometry, one of the things you probably talked about was parallel lines. A transversal that cuts through those has angles that develop on the inside of the parallel lines. If we look at this angle here, which would represent the same position as this angle we're working with, that angle, if it's not in our triangle, can be flipped around using the idea of alternate interior angles. Alternate interior angles are equal, so if we have this angle that we know, that's going to be the same as this angle here. So if we knew that this angle was 50 but it wasn't in our triangle, we could just simply put the 50 down below. If you set up that triangle, you would still get the same result. So know that we're not done with this question. We would need to go ahead and multiply both sides by 510 and we'd round to whatever they say. So you can look back to example 1 that we did today as the final answer for this.